Alright, hello everyone. Welcome to our today's lesson on what is power. Right, so our last lesson we learned about square roots and squares, but this time we're gonna learn a bit more about exponents and stuff. Alright, so hopping into our lesson here. Alright, mathematicians like me are super lazy. Right, if we have a bunch of numbers multiply by itself a bunch of times, we don't want to write it out all the time. Right, so instead of writing out 2 times 2 times 2, right, we just use exponents. So in this case, we have a little number on top, like the square we did earlier. Right, and now 2 to the power of 3 is the same thing as 2 multiplied by itself 3 times, which is 8. Right, because 2 times 2 is 4, and then 4 times 2 is 8. Right, so that's what exponents are. It is a number multiplied by itself 3 times. A common mistake I always see students make is multiplying those two numbers together. Right, so 2 to the power of 3 is not 6. It's not 2 times 3. It is 8. Right, and I should probably mention this too. To say it in English, we say to the power of. So in this case, it's 2 to the power of 3. Right, so we can actually check those out. 2 to the power of 5. So this is for saying, what is 2 times 2 times 2 times 2 times 2? Alright? And from here, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. So 2 to the power of 5 is 32. Alright, and then 3 to the power of 3, a little confusing. Right, but remember, it's 3 times 3 times 3. Right? Okay, it's not 9, it's not 3 times 3. It is 3 multiplied by itself 3 times, which is 27. 2 to the power of 6. Right, so we can lay it out again. Right, we can do the whole 2 times 2 times 2 times 2 times 2 times 2. Don't know how many times I said that. Right, or we actually notice here that 2 to the power of 6 is just 2 to the power of 5 with an extra 2 tagged behind it. Alright, so it's just 2 to the power of 5 times another 2. Oops, not really, right? We got 2 to the power of 5 here with an extra 2 behind it. So it's just 32 times 2, which is 64. Of course, you can do it from scratch as well. How about fractions? Exact same thing. So this is just 3 over 4 multiplied by itself 3 times. Alright, remember, with multiplying fractions, like we reviewed in Unit 1, numerator does numerator, denominator works as denominator. Right, 3 to the power of 3 is 27, 4 to the power of 3, 64. So like that. And now with powers of 10, right, this is a bit easier. Right, with powers of 10, this exponent literally just tells us how many zeros there are. Right, because if we multiply 10 by 4 times, we get 4 zeros. So it's just 1 followed by 4 zeros, which is 10,000. Right. Of course, if it's 10 to the power of 70, you have 1 with 70 zeros. And of course, anything to the power of 1 is just 1. What number it is? It's power 1, just by itself. Okay. So now, that's what exponents are. Of course, negative numbers make it a bit more complicated. Right, because whenever you multiply with negative numbers, we always have to make sure to check the brackets. Right, so we got negative 2 squared. Right, notice how the negative here is inside the bracket. So this whole thing is raised to the power of 2. So it's negative 2 times negative 2, which is 4. Right? Two negative numbers make a positive number. But right here, right? Once again, it's a negative 2 multiplied by itself 3 times. Right? This will be a negative 8. Right? Because negative 2 times negative 2 is positive 4. A positive 4 times a negative 2, it's negative 8. Alright, and now in this case, the negative signs are actually outside. Alright, this exponent here now only applies to this 2. Alright, this negative sign is not part of the exponent anymore, right? Because it does not have brackets. It's quote unquote outside of the exponents here. So we leave the negative sign in front, and then do 2 to the power 4. Right, which is 16. Right, so be very careful here. And of course, just for fun, we can combine all of them together. So this negative sign is left out at the front, whereas this negative 2 here is part of the exponent. Right, so it looks like this. Right, as a reminder, I just realized I'm writing this now. As a reminder, when there's no signs in between the brackets, that just means to multiply. Again, mathematicians, super lazy. Right, because we don't want to just write down multiplication all the time. Alright, and from here, negative 2 to the power of 5, as we saw earlier, right, 2 to the power of 5 is 32. And with negative 2, right, those will be an even number here. Okay, that's 4. Times negative 2 is negative 8. Times negative 2 is positive 16. Times negative 2 is negative 32. Alright, so we have negative 32, still with a negative sign in front, right? Because that one is not part of our exponent. Negative, negative, 32. Right? They combine to be positive. Right, so now what do we notice here? Right. We actually notice a pattern here. If the exponent is odd, right, if the exponent is odd, say to the power of 3, our answer will be a negative, right? Because every single time there are 2 negative signs, it makes a positive. So if there is an extra negative sign, it makes everything negative. Right? We have 2 negative signs. We get a positive number here. That's squared. And down here, negative 2 to the power of 5. Right? We get 5 of those negative signs. In the end, we got a negative number. Right? So which means that whenever we have a positive or a odd exponent, it's going to be negative. And then whenever we have an even exponent, it's going to be positive. Right? So that works for any single number, right? Because 2 negative signs cancel out to be a positive sign, which is an even number. So it literally does not matter what exponent it is, as long as it is odd, like in this case, right? Because it ends in a 1, it will always be negative. If it's even, ends in 8 here, it's positive. Of course, this only applies when there's a sign, the negative sign inside the bracket. If the negative sign is outside the bracket, then it doesn't really matter what the exponent is, it will always be negative outside. Okay, how about 0 now? So, once again, 2 to the power of 3 is 8. 2 to the power of 2, 4. 2 to the power of 1 is 2. How about 0? Right, what pattern do we notice here? Right, to go from 8 to 4, divided by 2. 4 to the 2, divided by 2. Right, so by this logic, if we go down by 1 more, just divide by 2, which is just 1. Right? And this means that every single number to the power of 0 will always be 1, no exceptions. So I can take a really random number like 2,700 whatever to the power of 0, that's also 1. So any number to the power of 0 is 1. 0 to the power of 0 is illegal. Right, so everything to the power of 0 is 1. 0 to the power of 0 is illegal. That cannot happen. Okay, so with all the exponents out of the way, all right, let's actually use them in word problems. You know, I love word problems. Right, we can actually use the math that we learned. Right, so let's say Mr. C here is 3 meters tall, right, which I definitely am, and I drink a cup of bubble tea that doubles my height. And now, if I want to reach 800 meters tall, how many bubble teas do I need to drink? Right, so let's do a little chart here. So I start at 3 meters, and that's when I have drank 0 cups of bubble tea. Right? After I drink one of them, one bubble tea, I go to 6 meters. Right, after 1 cup. Right? I just double my height. Next is 12, 2 cups, 24, 3 cups, 48, 4 cups. Right? That's 6. 384 is 7. Oops, we're running out of space here. That's all right. Okay, let me scooch things around here. 1 second. Uh-oh. There we go. One last drink. Oh, almost one last drink. Right, it's 8 cups. So of course, after that, we know for sure that by 9 cups, right, I will reach above 800 meters tall. Because by 8 cups, I'm at 768. So now, how can we represent this using exponents? So at the beginning, we start with 3. Right? And then, actually, we don't have to write this down right now. Right, to go from 3 to the 6 meters, right, to go after our first string of bubble tea, we just double in our height, right, to get to 6. And to go to 12 meters, we double, we multiply 2 by 6 again. So you can think of it as 3 times 2 times 2. And then we double again from here. So 3 times 2 times 2 times 2. Right, so every time we drink the bubble tea, we double. So we multiply by 2 each time. And you can probably see a pattern already here. Right? The 3 does not change, because that's where we start at. But every time we drink bubble tea, we double. We put a 2 on top of the multiplication. We multiply by 2. So our height can be represented by 3 times 2 to the power of n. And the n is the cups of bubble tea I drink. Right, which we can double check here, right? N, if we have drank 0 cups of bubble tea, right? So cup 0, n equals to 0. 2 to the power of 0 is just 1, so 3 times 1 is 3. Right? After we drank 1 cup of bubble tea, n equals to 1. 2 to the power of 1 is 2, times the 3 is 6. Right? We can check it's a bigger number here as well. Right? Let's say after 6 bubble tea, right, n is 6, so 3 times 2 to the power of 6 is 3 times 64, which is 192. Right, as you can see right there. Right, so we can use exponents to represent multiplication like this. And of course, after I drink 20 cups of bubble tea at n equals to 20, right, we can just plug it in. Right, we can just plug it in, and of course, like I said here, you can use a calculator. Right, doing this by hand does not make you extending. This just makes you waste a lot of time. So, 2 to the power of 20 is 1 million something times 3 is 3,145,728. Right, and if you are curious, again, just for fun, the distance from the Earth to the Moon is 384,400 kilometers. Okay, so I'm really close to just be able to grab the moon from Earth. Right, I bet Group will be pretty happy about that. So now, our last question. Right, we want the difference of volumes. Right, so as we remember, the volume of a cube, or the volume of anything, is the length times the width times height. Pretty much just all the side lengths multiplied together. That's what the volume is. But in the case of a cube, right, because a cube, by definition, a cube has the same side length on all sides. So, the volume of the smaller cube is just 4 times 4 times 4. And the volume of the bigger one is 6 times 6 times 6. Right, again, we just multiply all the side lengths together, and in the case of a cube, the side lengths are all the same. And 4 to the power of 3 and 6 to the power of 3, respectively, is 64 and 216. Of course, remember our units is cubed. And fun fact, that's why we call it cubed. 4 to the power of 3 is the same thing as saying 4 cubed. And the reason why it's called 4 cubed is because we're just finding the volume of the number. Right? Same thing as why we call something squared is find the area of a square. Something cubed is the volume of a cube. Of course, we want the difference of volumes. Right? So we just subtract them. 216 minus 64 gets us 152 centimeter cubed. Right, and we're done. Right, so that's pretty much today's lesson on how exponents work. Right, so again, the whole point of exponents is for mathematicians to save some time and just write our repeated multiplication with a simple number. But be very careful here. This is 2 multiplied by itself 3 times, not 2 times 3. Right, every time you multiply exponents like this, a puppy dies in the world, so please don't do that. So with that being said, all right, good luck practicing.